In Scuderia Ferrari Racing News, we find ourselves at the Fiorano track with the imposing F104S, which was donated to Scuderia Ferrari by the 51st Squadron of the Italian Air Force. Several years ago, the aircraft took part in a special duel with Gilles Villeneuve's Ferrari 126CK, with the Canadian winning the day. The Starfighter was the first fighter plane to deliver exceptional performance, which the Formula One cars of today are still pursuing, with ever more extreme aerodynamic configurations. We went in search of an understanding of the aerodynamic data gathered from a race car from two perspectives, that of the driver, Felipe Massa, and that of Alex Cinelli, head of Aero Performance Group.
Well, aero test is a very different test compared to the normal day of testing on the track. So normally when you do aero test, you do in the very long straight, you know, which the corner is a little bit less of important, you know, compared to the test. And we always do consistent speed. From, I don't know, 150 all the time, 150, and then to maximum speed. So you're doing many times this kind of consistent speed to check every difference between one piece to the other piece. For example, one rear wing to another one, and everything which is related to the aerodynamic, you know. So it's a very long, it's a very important, because you can understand on the consistent speed, you can understand the difference between one piece to the other one, and it's a lot to do for even on the driver point of view, but also for the team. Very boring, because it's not a test. I mean, the driver loves to go in the track to drive on the limit, to have a comparison, to have the lap time, you know, to improve yourself looking the lap time, to improve yourself even looking the others, you know, to have the competition, you know, with the other cars, with the other teams, with yourself as well. So when you are in the aero test, nothing is important. The only important thing is to developing the car, is to looking for these pieces, which is very important. But the driver is not really a driver there. He's like a normal, for example, a normal road car driver, you know, because you just bring the car. So you're not using the car, you know, you're just bringing the car around just to see which is the best aerodynamic direction, actually. Aero test, because they in the simulator you're driving like you're doing the normal test. I mean, you have the lap time, so you're checking piece by piece, you're improving, you know, you see which direction is the best or is worse. So, and in the aero test, you're not really driving. I mean, you're just checking the difference between the pieces, and it's very boring. I mean, simulator is you're closing on the room, but which is not very nice. But anyway, you're leaving what you're leaving on the normal test.
When the car is running on the track, we have a lot of sensors, and we measure over 150 sensors, and we use this to understand what the car is actually, how the car is behaving. So on top of the driver comments and the driver feedback, and the lap times, of course, there's a lot of people back in the garage analyzing data. So to analyze this data, we've got to acquire it. So via all the sensors on the car and the telemetry systems, we measure all sorts of things like the pushrod load cell, so how much downforce the car is producing, the airspeed, the temperatures, the accelerations, the ride heights, what the suspension is doing, the temperatures for the engine. So basically every part of the car is looked at, and there's a group of people that look at each section in the car. So we've got obviously all the electronics people to make sure that the car is functioning properly, and we're acquiring all the data. And then we have the aerodynamicists, the engineers, the mechanical engineers, the race engineers, the engine guys, and we're all looking at data that's being acquired while the car is running. An aero map is basically a way of describing a measurement that we do on the track, that we basically don't do any normal running, so we stop what the driver normally, on a normal lap, the driver would tend to drive as fast as he can and try and push the car to the limit. On an aero map, we don't. During an aero mapping test, even on a Friday morning, for example, of a race weekend, what we do is we do specific maneuvers that allow us to make a more consistent and better measurement. So basically we may do a constant speed. So basically we run the car at, say, for example, 200 kilometers per hour, and we acquire data for a long period of time, or a longer period of time than we would normally do during a normal run, because the conditions are just more stable. And having stable conditions allows us to have a better measurement. And so when we do comparisons of components, we very often do this and make sure that, again, we have a good measurement to be able to then make a decision as to what we leave on the car. An aero test is very important because it allows us to measure the car's aerodynamic characteristics in a very more detailed fashion than what we can do during a normal lap at the track. So for example, say we take a race weekend, we have very limited amounts of tires, we have very limited running time, and we have to really focus on optimizing the car and with the driver feedback and get the balance right and really try and make the car go as fast as possible. And that's our objective during a race weekend, of which on the Friday we do some aero mapping and some aero tests to understand the aero performance of the components or developments that we bring, but we really have limited time. So during a dedicated aero test, our main objective is really focusing on understanding the aerodynamic characteristics of the car. And we do this by putting the car in different conditions. So for example, the ride heights of the car can be high or low. We can have very different flap angles at the front or rear wing angles on the rear. And we can really test all different combinations or all different aspects of the car's tunable characteristics to try and determine the aerodynamic behavior of the car. And we compare that to the wind tunnel and try and assess the correlation that I was mentioning earlier to understand differences. And at the same time, obviously during an aero test, we normally always bring new developments, and we try and assess whether these new developments work and make the car go faster, or if there's problems. And very often we test new components, we check that they work, we understand if there's any differences to what we expect from the wind tunnel, we quantify them, and then we go back and we say, okay, how do we optimize the car with this package to get the most out of it during a race weekend? So then we'll go on a Friday, we'll let the driver test it, we'll confirm that the performance is there, the car goes quicker, and then we leave it on the car and try and win the race. The weather conditions are very, very important, because obviously when it's raining, for example, or very, very windy, the measurements become very, very difficult. We have to remember that the car's aerodynamics are a function of the speed and the airspeed over the car. And that airspeed over the car is very much a function of the conditions. So if it's very windy, or if we have a lot of wind for example, from the side, the car will see different yaw angles, for example, in the car. We'll see the wind coming from different directions. And normally when we have high wind, it's also very gusty, and we have wind coming from different directions. And so the measurement is very difficult, or more difficult, to have a consistent measurement. So, for example, you might test the same thing, and during different tests, you might measure different things because the conditions haven't been the same. So we have to be clever in accounting for these changing of conditions. Obviously, the more stable the conditions, the easier the measurement's going to be. Okay, very often we hear about terms like car efficiency and drag, and obviously many people sometimes get confused, but it's really quite simple. The Formula One car, a bit like a simple, if you consider, for example, an airplane has wings, and there's two fundamental forces that come at play. The faster you go, whether it's an airplane or Formula One car, the more downforce one generates with a car, or an upwards force for an airplane. So lift and downforce are the two terms, and it's a vertical force that either pushes, in the case of a car, pushes the car down. In terms of an airplane, it lifts the airplane up. And at the same time that these forces are generated, we also have the drag force. So that's basically a resistance, or basically to the forward direction. So it's a force that's pulling you back. and so that the more downforce you generate, the more drag you also generate. And this is just simple physics. And one of the balance between the two is basically the term efficiency. So the more downforce the car has and the less drag the car has, the more efficiency the car will have and the faster it will go. On specific aero tests might be boring because the driver just very often, for example, if we go to a straight line aero test, just goes up and down the whole day. But I think the race drivers and the test drivers know that the objective of an aero test is to find performance and understand how to optimize the car and make the car go faster. So during a Friday, for example, the race drivers know very well that doing these sometimes the constant speed measurements or doing specific maneuvers for assessing the aerodynamic performance is important for them, because we get the data, we elaborate, we try and understand the performance impact of these new components, and then make sure that we make the right decisions for the race. During an aero test, for sure, it's not the most exciting of things for a driver compared to finding lap time when driving around a normal track. But it's a fundamental part of our job and a very important part, because it's the best way it's the best thing we can do to make sure that we add performance. And as you know, aerodynamics and aero performance is fundamental to Formula 1 car. Very often when we do aero tests, you'll see what we call the roll hoop pitot, which is it's a device that allows us to measure the airspeed of the car in a different position to where we normally measure it. Normally, on the nose of the car, we have a pitot that measures the airspeed, and which is what we use normally during a Friday, or in fact during a normal race weekend. But when we go aero testing, we add this to the car, which allows us to make the measurement of the airspeed in a higher position, and it's basically less influenced by the details around where the nose pitot is normally affected by, and we have a nice clean measurement of the airspeed, which is basically a combination of both the car speed and the wind conditions, and which is a fundamental parameter, because the aerodynamics of the car, the downforce and the drag, are all a function of the airspeed around the car. We have two, simply because as a fail-safe mode, in case one breaks and in case we have a problem, we can switch to using the other one without really coming back into the garage and fixing it and wasting the run. So basically, when we do aero testing, we've got to maximize our running time, and this is just a simple way of making sure that if we have a problem, it doesn't stop us, so we can continue during the test. One of the things we do very often when we do aero tests, but also you'll see it also on a Friday running, perhaps during a race weekend, is what we call flow vis. This is simply applying a paint with the special powder that leaves the trace of the direction of the flow and the state of the flow, so the boundary layer, and we try and understand the flow characteristics on the surface of the car. We apply this to the front wing, the rear wing, the diffuser, generally anywhere on the surface of the car, and it gives us a lot of information as to where the flow is going, and we do a lot of comparisons with the wind tunnel and the CFD data, and allows us to really understand the correlation and try and also give us an idea on the performance of the car, as the flow quality of the car is directly proportional to the performance of the car. So we really, it's a very useful tool that as aerodynamicists we try and do as much as possible.
With the next test at Barcelona coming up soon, Felipe Massa assesses his first stint at the wheel of the new F2012 when he was testing at Jerez da Frontera circuit.
Well, actually, I was in Maranello for 2 days of testing on the simulator. So we check everything we did in Jerez on the simulator. So everything we work on the setup, everything we work on the new car, every direction we follow from Jerez, we try there. We see also the difference between the reality and on the simulator. And on the second day, on the morning, I was still in Jerez, but in the afternoon I was in Barcelona, already to start, you know, our direction in Barcelona, which we're gonna start now. So, and I think it was very important, you know, just to have some ideas, not just for Barcelona, but also already for the first race. And that was actually my job these 2 days in the simulator. Well, the main feeling is that we are still at the beginning. It's a lot to do, it's a lot to work on the car, it's a lot to find the right direction in terms of developing, you know, the car. And unfortunately we didn't drove as much as we supposed to, so it's always better to do more than 100 laps per day, and it was not the case. But anyway, it's still a new car, so it was the first time we drove with this car on the track, and I hope now everything is more or less prepared for Barcelona, and also we find the right direction for, you know, to have the right car on the first race.
And that's it for now, so see you next time.